In this example, we're going to look at how we form piecewise functions based on some sort of electronic utility use. Now remember, piecewise function is a function built from pieces of different functions over different intervals. So if we look at this example, they're talking about payphones, and we still have payphones even though people have cell phones. Sometimes they don't work and you need to make calls while you're out in public. So especially places like airports, they still have payphones. A payphone in our example at the local airport charges 35 cents for the first 3 minutes or part of. So that means if you make a 2.5 minute call, you still get charged for 3 minutes and 19 cents for each extra minute or part of. So if your total phone call is 3.5 minutes, that's a half a minute over the 3. So that means you're going to have to pay for an additional minute at 19 cents. You get charged for an entire minute regardless of the portion of that minute you used. Find the cost of a 7.5 minute phone call. So the first thing I like to do is to list out, what do we know? Well, we know the first 3 minutes is 35 cents, and we know it's 19 cents for each additional minute. The next thing we need to figure out is how much over 3 minutes were used. So we would need to subtract 3 from the 7.5. That would give us 4.5. Remember, we have to pay for any portion of the minute over, because 4.5 has a half a minute over 4. That means it gets bumped up to 5 minutes over. The last step would be calculating our cost. So 3-minute cost plus each minute over 3 times 19 cents would give us our total cost. We would put 35 cents in for the 3-minute cost, 5 times 0.19 for the 5 minutes over, calculate it out, and we would end up owing $1.30 for the phone call. Find the cost of a 12.25-minute phone call using the prices above. Pause the video and try it yourself. You should have come up with a cost of $2.25. When we create a piecewise function based on the information we saw in the previous example, we're going to use the greater integer function. That was introduced in the first lesson set. So a step function uses the greater integer function. So f of x equals x with the bracket with the extra line is how it is denoted in symbol. And what that means is the greatest integer less than or equal to the x. So if we look at our graph over here, you can see if we were to choose 3.5, it falls right here. So if we go to the right, we have an open circle, which, as we know, means it's not part of the solution. So we would have to actually go backwards. So that means 3.5 would actually be 3 in the greater integer function. Pause for a minute and try the examples. These are the answers that you should have gotten for your examples. So the greatest integer of -1 would be -1. The greatest integer of -1/2. Now, I know it seems counterintuitive, but it's really -1. And if you go and look at the graph, -1/2 is right here. And remember, when it's a negative integer, as you go to the left, the numbers get higher. So the greater integer of negative a half would be -1. The greatest integer for 1/10 would be 0, and the greatest integer for 1.5 would be 1. Now we're going to use the greater integer function to express the payment from example 1 as a piecewise function. So what we're going to do is we're going to let m equal the length of call in minutes, and C of m would be the cost of the call. And we're going to write a piecewise function for example 1. So we're going to write 3 different functions and one of them will use the greater integer function. The first step would be write a function for a call 3 minutes or less. So that means that C of m would equal 35 cents. And remember, you have to put conditions when you are creating a piecewise function. So in this case, when we write a function for a call 3 minutes or less, it's 35 cents. And we would add the when m is less than or equal to 3. When we want to write a function for a call longer than 3 minutes, well, one of the functions that we would use would be C of m equals 35 cents plus 19 cents minus the minutes over times the minutes minus 3, which would indicate the amount of minutes over 3 that were used. That's what we figured out in step 2 in the previous example. And our condition for this would be when m is greater than 3 and m is an integer. So that means it's a whole number. The third step would be writing a function for a call longer than 3 minutes, but m is not an integer. So this is where we want to use our greater integer function. So if you compare step 2's function to step 3, you will notice that in step 3, we added the greater integer function around the m minus 3, and then we added the plus 1 to increase it because the greater integer function takes it down, but we have to pay for that extra part that's over. And once again, we put our condition, in this case, our condition states when m is not an integer. The last step would be to combine all 3 of the functions together. And you put them all with a big bracket on the left. You make sure that you incorporate your conditions with each line that it matches. So this one I want you to try on your own. A payphone at a baseball stadium charges 65 cents for the first 5 minutes or part of, and 22 cents for each extra minute or part of. Express the cost, C of m, of an m-minute phone call as a piecewise function using the greatest integer function. Pause your video and attempt this. Check your understanding. Hopefully, when you attempted to solve this, you ended up with the following piecewise function.